get going here. What I want to talk about today is the focus is going to be on depreciation. So there's definitely going to be a focus on depreciation. And in terms of depreciation, there are two types of depreciation. There is what we call straight line depreciation, and we have reducing balance or diminishing balance depreciation. So let me reducing balance depreciation. And knowing which formulas go with which is important. So straight line depreciation is kind of like the cousin of simple interest. And so the only difference in the formula is going to be like that. Reducing balance depreciation is kind of like the cousin of compound interest. And it looks like that. So you're going to see that those formulas are going to be sort of being very much in focus today. And just like in the last lesson, the A, P, I, and N stand for the same things. The other part of the thing that we're going to see today, let's see why my pen is being funny, is a formula that converts from what's called the nominal interest rate to the effective interest rate. And the effective interest rate is kind of like the interest rate that incorporates all the effects of compounding into 1 year. And the formula looks like this, 1 plus I nom. And so you need to know how to go between, for example, this one and this one. And normally how this would happen is I would give you something like, you're given a quoted interest rate of 12% per annum. So that's the nominal interest rate. And they say that you want to compound this interest rate monthly. What is the effective interest rate? And in fact, let's just do it together now. So in interest land, 12% as a decimal is 0.12. And if I'm compounding monthly, the M is going to be 12. So to work out my effective interest rates, what I'm going to do is I'm going to replace the I nom with 0.12. I'm going to replace the M with a 12 because we're compounding monthly. The M up here is a 12, and then I go -1. And that would give me the effective interest rate. Now, I want you as students to put that into your calculators now and see what you get, and then put it in the chat. So, and then we'll talk a little bit about what you get. But basically, all I want you to do is take this calculation, put it into your calculators, and tell me what you get. Oh, I see a question. Who has a question?
Bonolo.
Yeah. Hi, Bonolo. What's your question? You can unmute yourself, Bonolo, at the bottom. There's like a little thing that pops up.
Good evening, everyone.
Hello.
Hello.
So when we done getting the answer right, we at my school they said we should times by 100 so that we can get the percentage. Is that right?
Okay, yeah. So when you get the answer, it's in decimal, and then in order to go from decimal to percentage, you just times by 100. But it's the same way that if you go from percentage to decimal, you generally divide by 100. So it's just the other way around. But let's see what everyone gets. So you're quite right, Benolo. That's, if you write it as percentage, that would be, it just depends on what they ask in the question, but yeah. Okay, so let's have a look at what everyone's getting. I'm seeing the I effective is 0.1268, which if we take Benolo's question we applied, in terms of percentage, that's going to be 12.68%. So the nominal interest rate that was quoted was 12% per annum, but when we break it up into monthly chunks, the effective rate ends up being 12.68%. Now, I just want to ask, why is the effective rate higher than the nominal rate? A bit of a sneaky question. Well, not that sneaky, but like, why is it higher? Like, what makes it? Any ideas in the class? Because the quoted rate was 12% and the effective rate ended up being more than 12%. Anybody have an idea? Pop it in the chat or raise your hand. So what happens is with compound interest, you get something called interest. Oh, Lee, let's go to you. What do you think, Lee?
Hello, sir, and hello, everybody.
Hey.
So basically, the reason why the nominal rate and the compound, the thingy, the effective rate are different. The nominal rate is what they quote you at. This is the quotation they gave you, and then the effective rate is what they then charge you.
Okay.
If I'm not wrong.
No, so you're on the right track. So it's the quoted rate, but it's this idea that of interest on interest. So if you chop up your interest periods into months, you get a little bit of interest on the first month, and then that bit of interest gets added back to the original, and then the next month you get interest on not just the original bit, but the first month as well. So Nadia said the effect is compounded. So basically, the effective rate takes into account the effect of compounding. And that's why it's called the effective rate. Thanks, Lee. And thanks, Nadia. Okay, so let's get to, that's just a little bit of getting ready for today. And let's go to some questions now. Oh, Lasanda, what's your question?
Hello, sir.
Hey.
So I wanted to confirm the equation for finding effective rate. Doesn't it you say plus IE equals to 1 plus I norm over M to the square root of M?
To the power of M, yes. And what I do is I move the 1 to the other side. In terms of the -1 is here at the end here. So that's what you see on the screen here is correct. If you had to find, if they gave you the effective and you had to find the nominal, you would have to just move it the other way around.
Okay, thank you.
But we'll see what exam questions look like. Okay, so let's just start with this question just to make sure. Let's do that one first. So a car is worth 120,000. It depreciates at a rate of 12% simple interest per annum, or another way of saying this is straight line depreciation. How much will the car be worth after 5 years? And I'll even give you the formula. So off we go. What do you get? Just want to practice all the key skills for depreciation. Depreciation is just losing value. That's why there's a minus in the formula. I see students working hard. Pop your answer in the chat when you. So that wasn't too bad. Let's see what the answers say about this one. Yeah, so my answer agrees with you. We end up with 48,000 after 5 years. Now, you'll notice that, okay, I want to ask another question now. If the car is worth 48,000 after 5 years, how much value has been lost, or what is the amount of depreciation that has, how much value has the car lost? Because you're telling me that the car is worth 48,000 now, but I want to know how much is the depreciation, how much value has been lost. Pop your answer for that in the chat. Okay, so you guys are clever. So you started out in life with 120,000. That's how much it was worth originally, and in the end it was worth 48. So the depreciation will just be whatever that is, which is 72,000. Okay, awesome. Let's move on to, I like what I'm seeing in the chat. Well done, Mikal, Tondol Wetu, Kinas, looking good. Now, similar question, except now we are using the reducing balance method, and let's see what we get. See what we're starting with the same car. It's worth 120,000 and it's depreciating at 12% per annum, but it's reducing balance this time, reducing balance depreciation. And I want to see, what do you guys get? So off we go, and let's see how different our answer is. All right, so I see lots of people are putting answers in around 63. Let's see what the answer says here. So we should be getting 63,327.83. Yeah. So I don't see any problems in the chat at the moment. Please do raise your hand if you have a problem. Or you want to ask a question, but I think from what I'm seeing, we can move on and into another question. So that's the basic depreciation questions. Let's have a look at a combined question now. So before we do this question, I want people to tell me how this question, so let's read the question. I'm going to give you 30 seconds. And then in the chat, I want you to tell me what's different about this question compared to the last one. So just take 30 seconds, read the question, and then let me know in the chat what's different about this one compared to the last one. Okay, so we're not given the percentage, or we're not given the rate. And Nawazi said they're asking for the interest here, or you have to calculate the interest rate. Yes. And on Tukoza was also said we don't have the rate. So if we look at, normally we are given either A or P, but in this case, we're actually given both of those. And we're also given N, but we're not given I. Okay, so let's start with this question. I want you to think about this question and try and find me. Now, the interest rate, is the depreciation rate. So you know that the formula that you're going to be working with for simple straight line depreciation is going to be that. I want you to find me the answer for A. If you don't know which numbers go with which, you can raise your hand or ask a question. But I think for most of you, let me know if it's something different, but see if you can solve for I in this case. I like the comments in the chat. They're very accurate. yeah, like Lev was saying in the chat, if you do have a question, please, the wonderful thing about being on the internet is, like we're all here together, you can ask your question, and yeah, there's a math teacher here to help you. But if you feel comfortable, just go ahead and work out the answer and put it in the chat. There's actually a couple of ways you can do this. There's not actually one method. So we'll look at that now. So I think those are the two main methods. One method is to sub in and then rearrange. And some of you will rearrange it first and then sub in. Those are both valid methods. Well, let me bring this back so that we don't. So we start at 10,000 and we end up with 5,000. And then the time period was 4. So that's what I was, if you sub in, that's what I would have got to sub in. So this, I'll call this method 1. Some of you may want to rearrange it first and then sub in. I don't know which method you would prefer, but for now, I'll just stay with method 1, unless there's a question that wants me to do it with method 2. And the problem is I need to get this I by itself. And what's stopping me at the moment is this 10,000. And so I'm going to move that to the other side, or I'm going to divide it by. And then also I times 4 is just 4i. So I get that. And you know what? 5,000 over 10,000 is just going to be a half, or 0.5. And so I get that so far. Okay, Tando Wetu, what's your question?
Good afternoon, sir.
Hey.
My question is, when we're dealing with simple interest, it's different from depreciation, from DK. So now, does that mean that the value of P will always be bigger than the value of A?
That's a good, yeah. So when you deal with depreciation, because you start off with a certain amount of stuff and you lose value, the P value will be bigger than the A value. Yeah, it's
okay,
a very good insight. Yeah.
Thank you.
Everyone get that. Yeah. Because it's almost like one of the mistakes you can make is you can have the 10,000 going to the wrong place. And because you start, P is what is your initial, and because you're losing value, that's why there's the negative in the formula. Okay, and so then if I look at my working, I'm now going to say, I'm going to move the minus 4i to the other side to get 4i, and I'm going to bring this to this side to get that. And then my last step, well, almost last, so 4i is 0.5. And then if I divide both sides by 4, I is 0.125, or in terms of percentage, it's going to be 12.5%. Per annum. So I should actually put that in. Sorry, guys, we must also put the. All right. Okay, so that is the simple interest part of things. Just give me a thumbs up if you're feeling good. Thumbs down if you're feeling a bit unsure. Okay, now I want you to attempt the reducing balance depreciation. So it's the same rough calculation, except, so the basic information is the same, but you're no longer going with straight line depreciation or simple depreciation, you're going with reducing balance. Yeah. Atlehan, let's go to you. What's your question?
So it's a mistake.
Oh, it was a mistake. Okay. No problem. All right, so everyone's doing the reducing balance depreciation question. And what do we get if we use that formula? It looks similar to the last time, but there's one important difference. I'm wondering if anybody can spot the important difference with B, and if they maybe have something that can help us. Let's go with this. Oh. Now, I should have put the n value in a while ago because the n value is 4. So that should be 4. Okay, we've got a little sticky problem. Now, how do we get rid of this thing over here, this power of 4? What undoes the power of 4? Okay, Lusanda, let's go to you. Can you unmute yourself, Lusanda? What do you think we need to do?
You're gonna multiply 4 by 1/4 to remove.
So there's two, it's not multiply. You can take the 4th root, or you can raise it to the power of 1/4. So there's 2 different ways of doing this. You need to deal with this thing over here. And so the one way of doing it is just to say, I'm going to raise that side to 1/4 and raise that side to 1/4. So I'm raising it to the power. And what that would do is it would get rid of this thing over here because they'd knock each other out. The other way of doing it, which is the same basic idea, is to take the 4th root on both sides. So you take the 4th root on this side and you take the 4th root on that side. So that's the same idea. And you're left with 1 minus I on this side. And then whatever your calculator says about this one. So let me use my calculator to do that. 4, and then inside the bracket 0.5, and I get a whole mouthful like 0.8408964. I really want to use my calculator memory in this case. And then if I bring the I to this side and I go 1 minus this whole thing, which I'm going to store in my calculator's memory, 1 minus answer. So whenever I press the equal sign, the answer key will store that there. And so we get 0.1591 and 0. And so as a percentage, it will be 15.91%. And this would be also per annum. Rate of depreciation is per year. Yes, it is. Okay. Are there any questions or comments about the difference? It's a little bit harder to find the depreciation rate when it's in the reducing balance method. You have to use the root form or the power on the same side. The basic idea is there. Okay. I like it, Gabisile. I like it. So, thumbs up if you're feeling okay with depreciation. We can move on a bit. Thumbs down if you're still feeling a bit unsure. Just want to do a quick little vote. Okay. see those hands, Luclea. I see them. Okay. Let's try and do one more question before the break. One more question before the break. Oh, I've got too many buttons to press, guys and girls. I need to watch out. Yeah.
Can you take a question before the next one? From Gabisile.
I can. So while I'm going to take a question now, but I'd like for students to attempt. This question says, what is the effective interest rate? And if 7.5% per annum, this should be compounded monthly. So compounded monthly. And I want you to think back to that formula from earlier in the lesson. Yeah, and then Gabisile, what's your question? So the rest of you get on with that. And then Gabisile, just put your hand up so I can see where you are and we'll unmute you.
Afternoon, sir.
Hey, how's it going?
I'm good. My question is, I used, instead of using a decimal, I used a fraction.
So instead of using, say that again, I lost you there.
Oh, instead of using a decimal, I used fractions.
Okay.
So I got a answer.
You got the same answer?
No, a different answer.
Okay, even if you use fractions, you should get the same answer. Where did you use fractions to start with? Which part of the question?
The 5,000 over 10,000.
Okay. Fractions, you should have got a half. You probably didn't. You probably wrote a different fraction.
Okay. Okay, I see my mistake now.
Yeah,
thank you.
Perfect. Pleasure. Okay. Okay, so the formula that I gave you earlier in the lesson for this was, and this is to convert, so from I effective 1 plus I nom over m to the power of m minus 1. And so I want to see, can you use that to find me the effective interest rate? So basically we're saying 7.5% per annum nominal interest rate. If I change that to compounding monthly, not yearly, what is the effective rate that you get by chopping it up into monthly portions? Keep those answers coming, everyone. All right, I like what I'm seeing. I like what I'm seeing. So I do have the answer here. And so, well, actually, let me write out what I would do to start with. So plus, so this is going to be 0.075 divided by 12. And that will be to the power of 12, and that will be minus 1. So what is the answer going to be in the end? Let me bring this down here. Oh, be a bit of a digital ninja here. Okay, so the answer we should get is 7.6 or 7.76%. Let's bring this back. So yeah, 7.76%. Okay, I think you guys are doing rather well. I'm rather impressed. And so what I want you to do with me now is we need to give our bodies a break. So I want you to turn on those cameras and I want you to stand up with me and stretch. And Lebo, if you can just help us get motivated here. Stand up, everyone.
Guys, please put on your cameras. We love to see your faces. Join us in the stretch.
Stretch it out. We've done half an hour of solid maths. I'm a maths teacher. Even for me, I'm tired now. Like, let's give ourselves a break. Stand up.
Give that mind a break.
Oh, there we go.
Shout out to Bonolo. Shout out to Sibulele, Kwezi, Ntokozo. Come on, guys. Don't get FOMO.
Look at that. Oh, some good stretching. I like that hand over head stretching.
Shout out to William. Yes.
Yes.
Shout out to Lutle. Shout out to Nolwazi. Awesome, guys.
Oh, doesn't that feel good?
Loving your energy. Shout out to Nolutando.
We weren't made to sit all day. Like that
And
is one
just
thing that
shake
you
it
feel
out.
to students. You got to tell your teachers, man, I need my stretching break. You got to tell them. Like
2
half an
minute
hour.
stretching break.
Oh yeah, you said my brain needs it. Okay. So let us go to a brain break question. So I'm going old school here. There's a whole bunch of sweets, and you need to tell me what that is. See what you guys can do it. This reminds me of Christmas sweets. You know, like they sell those special collections of sweets at Christmas time.
Oh, yes.
That's what I'm thinking of. Those little boxes, you know, like you, oh. Aha, I agree, Nowazi. I think the blue sweets might be the key to breaking this open. So this is definitely 3, 3, 3, and then 2 of these threes. So this is going to be 6 in total. So this thing over here is 6. And what's the red sweet going to be? So 6 times 2. You're right. So this is going to be 1, 1, 1, 1. We're getting closer. So what are the pink sweets going to be? And then if we get the pink sweets, we know we can figure out our final answer. Oh, aha. Answer is, okay, Jabulani's put an answer in. So is some other students. Let's see if I agree with them. 4 and 4 and 4. And that's 1. So according to BODMAS, the multiplication happens before the addition. And so my final answer is 13. Komotsile, Tato, Owazi, Molalo, William, on the money. Nobesetu, nicely done.
Well done, guys.
All right, we used to do these ones all the time. It's been a while since we've done them. But yeah, that is awesome. Okay, so just make sure, stretch out that body. We're going to do a second part of the lesson now, and then a little revision of, so let's go for this one. So first of all, I want to know, actually, let's do number 2 first. So I want you to do the one I'm currently coloring in. And I want to see, using the idea that we had earlier, can you find me the effective interest rate? So
Thanks a lot, AP, for bringing the tea to the table. Too bad you didn't do when you was working here. You might still have a job. Okay, so I need it. How do I get it? What we gotta do? I just need a little something for you. Let's talk numbers. Race coming up fast.
Okay. How are we doing on this one? So what I see is 0.092025. When written as a percentage, it'll be 9.20% per annum. Yeah. Alrighty. That was looking pretty good to me. Oratile, I see the answer. Manolo, Malalo, Siliziwe. Fantastic. Okay. So no problem there. Now, let us take a moment and go back to how much time have we got left? Okay, no, I tell you what, let's go straight on to an old exam question and have a look at an old exam question. So if you look at an old exam question like this, you can see that the very first question over here is about depreciation, right? So we've covered some depreciation questions today. And yeah, it tells us in the question that it's a straight line method question. And so based on what we've done today, that shouldn't be too hard to do. The second question is a question about interest rates. So let's have a look at this one. I want you guys to tell me what is the answer to this question, 4.2.1. Take a moment to look at that. So it says at what it says that the interest in the investment is at a rate of 8% per annum compounded quarterly. At what rate is interest earned each quarter? So it's a straightforward question. What do you think? If it's 8% per year, how much interest are you earning per quarter? Couple of students have locked the answer in. Very, very nice, guys and girls. Indeed, it's just going to be 8% divided by 4, which is going to be 2% or 0.02. Yeah, simple as that. Okay, now I want you to calculate the effective annual interest rate on this investment. Calculate the effective annual interest rate on this investment. And that will be similar to the questions we were doing above. Let's see if you can do that.
Come on, guys, you can do this.
We believe in you. So it's the same formula as above. What's the effective annual interest rate going to be for this particular question? So that's going to be 4, and that's going to be 4. Because it's per quarter. What's my effective annual interest rate? Now, I would expect it to be higher than my rate, than the 8%. And what, I'm just going to use the answer thing because we're running out of time here. You should get 8.24% per annum. Okay, so now I'm just going to give you, in your exams, getting those first 5 marks is going to be the most important thing for you when you deal with financial maths. But sometimes we also have a little bit of what's called a sort of a question where we have to set up a basic timeline. And all I'm going to do is I'm going to show you the basic thinking behind it. We're not going to do a deep example. I'm just going to explain how I would approach this question. So first of all, for 4.3, let's read through it together. 14,000 is invested in an account, and the account earns interest at a rate of 9% per annum compounded semi-annually for the first 18 months. And then it changes compounded monthly. So there's 2 different interest rates. How much will there be in the account after 5 years? So first of all, I want to ask you, what formula am I going to be using for 4.3? What is the correct formula for me to use for 4.3? You can come on over the microphone or you can put it in the chat, but I just want to ask you, what's the correct formula to use? Is it going to be a growth question or is it a depreciation question? So I want to suggest it's growing. And so it's going to be compound growth. And the formula that I need to use is going to be that one. Now, because of the fact that things change, in order to keep track of the stuff that's changing, I'm going to draw a timeline. And for me, this timeline takes place over 5 years. So I'm going to call this T0, and I'm going to call this T5 because it's over 5 years. There's one really important point along this timeline. Can anybody tell me what that point is in terms of years? What other point on the timeline is quite important if we are thinking of important steps in this journey? So there's the beginning, which is T0, there's T5, and then 18 months. Now, what is 18 months in terms of years? Because I want to keep it like in the same unit. So what is 18 months in terms of years? Isn't it just going to be T1.5 or T1.5? Okay, now, all I'm going to do, now that I've got the important points on my timeline, I'm going to illustrate where the interest rate is one type of interest rate. So 9% compounded semi-annually is going to be 0.09 divided by 2. And then for the second part of the journey, the interest rate is 0.075 divided by 12. Give me a thumbs up if you understand what my timeline is saying. I just want to check if you, so I've put these important dates on the timeline and I'm showing you where the interest rate is different. Visually, I can see exactly what's going on. Now, the final step is I actually have to think how much money is in the pot. And what I do is I put up my money below and I say, well, we started at plus 14,000. Okay, and so I said at the beginning of this question, so I'm going to do it for you. We started with this formula over here. So to start the journey, I go 14,000, 1 plus, and this is where I need to use the interest rate that is relevant for the first part of the journey. So it's this part. However, I'm going in half years because 0.09 divided by 2. So how many half years are there in this pink part? How many half years are there? So all I'm going to do is I'm going to go 1.5 times 2, or I'm going to end up with 3. There's 3 half years in this pink part over here. So think about it. If you've got 18 months, how many periods of 6 months are there in that part? There's going to be 3 lots of 6 months. Now, you have got to this point on your timeline. You still need to grow all the way to the end of the timeline. And so what you do, and guys, we're going to run out of time today, but basically what you do is you treat this thing over here as the input to the next part of the calculation. So the next part of the calculation looks like this, and it goes 0.075 over 12. And you have to ask yourself, how many months are there in the green part? So from year 1.5 to year 5, how many months are going to fit in the green part? Pop that in the chat. So I think that 3.5 years, I know that there are 12 months in a year. And so in 3 years, there's 36. And then for another half year would be 6. The other way of doing it, yeah, you're going to end up with 42 here. And so the final answer, if I go through all of this stuff, is going to be whatever comes out of my calculator when I multiply all these things together. Yeah, Nawazi, you're absolutely right. It's 42. Now, I'm going to put up the answer for you now, just so that you can see it. And you might want to take a screenshot, guys, of this one, because we might be running out of time here. Your answer should be 20,755.08. Now, if you want to see more timeline questions like this, guys and girls, I am going to be doing a few more of these in my next class with the standard guys. And so if you look at the recording, you can see a few more of these timeline questions. Okay, because I know we only just touched on this tonight, but I just wanted to show you that they're not impossible. You just need to follow a very structured process. Okay, Milano, how did I get to 42? So can you see the green part on my timeline? Can you see this part here? This goes from 1.5 years in to 5 years. And so that is the same as 3.5 years worth of journey. How many months are there in 3.5 years? Well, there's going to be 12, 12, 12 plus 6. Or another way of doing it would be to say 3.5 times 12, and you get 42. The same way for this first pink bit, you could also say, just say 1.5 years. And because it was half years, you go 1.5 times 2 and you get 3, which is the 3 over here. Okay. So, Lebo, could I ask you to please put the link to the quiz in the chat, guys and girls? So again, most of your marks are going to come from that first type of question. But if, as you're getting stronger and stronger at this, you can have a look at a timeline question, but I wouldn't obsess about the timeline questions until you've built a good foundation. Okay. And I just gave you a little taste today of what a timeline question looks like. All right, everyone. I think we're going to wrap up for today, but I hope that you enjoyed the lesson and that you got something out of it. And I will see you next week. Like I said, if you really want more timeline questions, look at the recording of the next class. And then next week, we start with trigonometry. We're going to be doing some general trig in the lesson.